very good day. Today we are going to learn the homoscedasticity assumption using SPSS. Objective of today's lesson is to check the homoscedasticity assumption of multiple linear regression using Breusch-Pagan test by SPSS. The BP test, where the null hypothesis is actually variance of residue is constant, which is actually homoscedasticity, versus alternative variance of residue is not constant, which means heteroscedasticity. If p-value of the chi-square distribution is less than 0.05, we reject null hypothesis. Hence variance of residue is not constant. If p-value of chi-square distribution greater than 0.05, we fail to reject H-null, means that variance of residue is constant, or homoscedasticity. However, there's no direct BP test in SPSS, hence we need to perform it manually. First step, we'll create the squared residue by going to the transform menu, compute variable options, type in res2, stand for the squared residue under the target variable, and then in the numeric expression box there, we key in the formula as a res_1 multiply res_1, where the res_1 is our unstandardized residue. Then click OK. So the res2 is dependent variable for the BP test. Okay. Step 3, we perform the multiple linear regressions by going to Analyze menu, Regressions option, Linear sub-option. Now we set our dependent variable as the res2. Independent variable still our x1, still our independent variable in the multiple linear regression model, and then we click OK. And then to obtain the BP test statistic, we can, from the model summary table, we obtain the R-squared value, use it to calculate the BP test statistic by n multiplied with R-squared. This is a BP statistic where n is the sample size, k is the number of predictors. And then step 4, decision. Okay, we compare the BP statistic with the chi-squared critical value with k degree of freedom 0.05, okay, significant level. We reject H-null if the BP statistic, which is n times R-squared greater than chi-squared critical. Okay, let's move to SPSS. Okay, we have seen in the previous video how we copy paste the data from Excel into SPSS. Now we would like to manually create the BP test. Okay, first of all, we go to the transform, compute variable. Okay, under the target variable, we put it res2, stand for the squared variable. Okay, but here res_1. Okay. Okay, because this variable not yet found, so we have to create that unstandardized residual first. So go to Analyze Regressions, and then the linear regressions. Okay, we would like to we have to move dependent as y, independent here, and then we need to save the unstandardized residue. You may save also unstandardized predicted. Okay, so now we got this. Okay, res_1 unstandardized residue. Now we go to the transform menu, compute, Okay, target variable is res2 squared, okay, residual, and then this is res underscore 1 multiply res underscore 1. Then we click OK. So here we got a new variable, which is squared of unstandardized residual. Okay, we use this res2 as a dependent variable. Now we go to analyze regressions, linear. Okay, now we move y back to the list. We choose res2 as a dependent this times, and then we just need the model fit. Okay, I'll continue and then okay. Okay, yeah. So you see now this dependent variable is a res2. The r squared value is 0.212, 0.212. So we have the sample size is actually we got 11 data, r squared from the regression of the res2. In the squared residual we get the 0.212. We got two predictors. So the BP test statistic will be 11 times 0.212. We obtain 2.332. The critical value of a chi-squared value, we got 2. Degree of freedom is 2. 5% significant level, we obtain 5.991. Since the BP value 2.332 less than the chi-squared critical, which is 5.991, it does not fall in the rejection region. Thus, we fail to reject H-NA. Conclusion, we fail to reject H-NA mean it is homoscedasticity present. Homoscedasticity present. Okay, how to get this critical value? Yeah, this is the chi-squared distribution. Significant alpha is 0.05. Where is it? 0.05 here. Degree of freedom is 5.991. Here. So I repeat again, in the SPSS, I think. Okay, we must create the res1 first. Res1 is actually under analyze linear. Make sure we save the unstandardized residual. So you create the res1 in the unstandardized residual number 1. And then we need to go to the transform menu, compute variable, target variable. We create a new variable, res2 stand for the squared of residual. That's why the numeric expression we type in res1 multiply res1, and then we click OK. Click OK. Cancel. We just cancel it, and then again we perform the multiple linear regressions. This round we choose a dependent as a res2, independent variable still x1 x2, and then the statistic, we just choose default is a model fit and estimate, and we click OK, and this one we just cancel it, and we get the output, which is here the model summary. There this r squared value, the r squared value is used to calculate the BP test statistic, which is 11 data times the r squared value, 2.332. Okay, the value is less than the chi-square critical. Okay, if less than here, if less than, so it's actually we fail to reject because it's not fall in the rejection region, so we fail to reject. If fail to reject means variance of residual is constant or homoscedasticity present. Yeah. So, okay, if the BP value less than the chi-square critical, it does not fall in the rejection region, we fail to reject. If fail to reject, H naught means okay, variance of the residual is constant or homoscedasticity present. Okay, with this, thank you for your attention.